Good afternoon. As Jody was saying, I'm in the process of completing my thesis project with the Sacramento County District Attorney Laboratory of Forensic Services, and my thesis project is on the homogeneity of soda-lime container glass. So the purpose of the presentation today is to kind of give you a feel for what some of the preliminary results are that we've been getting. So I was going to start out with a little bit of a background on the techniques, but Jose covered a lot of that, so I'm just going to kind of brush through that really quickly here. I'm sure most of you are familiar with the way glass examinations are done. Typically, there's a combination of refractive index measurements used and physical characteristics. And researchers started looking into elemental analysis about 3 decades ago because it provides information about the classification of product type and use. And it has been shown to be a discriminating technique for forensic analysis. Traditional introduction techniques for ICP-MS typically require that the sample be introduced as a solution, which, as you can see, would be sort of problematic when you're using glass samples. So the drawbacks that I'm citing here are they're focused on that fact. Number one, you're looking at dangerous digestions to break the glass samples down. This is usually a combination of an acid cocktail that you're using, and it can take up to 3 to 4 days to complete. And again, you're looking at sample size requirements that aren't always possible when you're doing forensic analysis, and it is destructive in nature. So researchers started looking into other methods of introduction techniques, one of them being the laser ablation method. And it has been shown to be a very viable method for forensic glass comparisons. The way it works is you have a very high-powered laser that hits the surface of the glass, and it sends up an aerosol of superfine glass fragments, which are then swept into the ICP-MS machine, broken down, and analyzed. So the advantages of this introduction technique are you're looking at decreased sample prep time. You no longer have to do these acid digestions, which are dangerous and time-consuming. For most laboratories, prep usually requires the samples to just be washed with an acid solution, and some laboratories do a pre-ablation where they just remove any surface contaminants, and then they take their analytical spots from within that area. You're looking at minimal sample consumption because you're only taking what you need for the analysis. It maintains good sensitivity for most elements, and there's less risk of contamination. So this project was focused on looking at homogeneity in glass bottles, and I forget who was talking about it yesterday, but it's important when you're looking at, when you're doing comparisons like this, you need to understand the homogeneity within a unit, so within a glass item. And for glass, this could be natural heterogeneity introduced by a manufacturing process, which would include contamination or natural variation in the raw materials because it is geologically specific. And especially with glass bottles, you're looking at the use of collet, which we saw in the video is it's either from the plant itself or for glass bottles, they take a lot of that from post-consumer recycling. So that's going to introduce some variation there. And also you want to understand how elements vary between glass samples, either within a manufacturer or outside of a manufacturer. So previous research on homogeneity, they have shown that laser ablation ICP-MS does reveal some small natural variations in glass. Whether or not this is significant for forensic glass comparisons is still kind of up in the air. I think for the most part they've decided that it's not significant. And again, as I said before, it's important that you're understanding the homogeneity of glass items when you're comparing samples from the same categorical sources, so you know what kind of variation is the natural variation that you might see, and when you're comparing samples from different manufacturers. Again, glass items typically maintain the homogeneity overall when we're working with forensics, so it's not necessarily significant. Glass of the same type can often be distinguished on an item-by-item basis using this technique, so it is valuable for forensics. But glass bottles do tend to be a little bit more variable just because of the introduction of the collet and the way that the bottles are manufactured. So the goals of this project were, number one, we wanted to look at homogeneity within a single glass bottle, and we wanted to establish the match criteria that would kind of balance out the false negatives and the false positives that we were dealing with. And we also wanted to look at how glass bottles vary within a manufacturer. So again, the project was completed in 2 stages. The first stage was to look at a single bottle as a unit and to look at the homogeneity and establish our match criteria using that. And for stage 2, we looked at these 3 different variables within a manufacturer. We had hourly runs where bottles were pulled from a production line on the hour for I think a couple of days they did that for us. The daily runs where they were pulled at the same time every day for a series of days, and simultaneous daily for multiple furnaces. What this means is that we were having bottles pulled from 3 different furnaces at the same time every day for a series of consecutive days. The samples all originated from the Gallo Glass Company in Modesto, California. They were typical soda lime, and they did use collet, and I think they verbally said in a tour that it's about 25% of recycled post-consumer glass. So for stage 1, we used 10 bottles from 2 of the main furnaces that we were dealing with, and we pulled 3 fragments from the neck, 3 from the sidewall, and 3 from the base, and we analyzed them inside and outside. And we tried to pull bottles that were representative of the population that we were dealing with. The way that the Gallo Glass Company works is they have their own wine bottling plant near the facility or in the facility, I'm not really sure. And so they make their own bottles, but they also contract out to other bottling facilities. So we're working with more than just wine bottles. There were lots of different types and colors of bottles that we were dealing with. And then stage 2, I think we ended up with 5 groups of 12 bottles and 1 group of 6 bottles, which I'll get into in a few slides. The way we did the analyte selection was first we compiled a list from the literature and from the standard reference material of what we might expect to see in glass bottles. And then we did an acid digestion of 5 bottles that we selected to be representative of our population. And based on what we saw from that digestion, that's how we established the analytes that we were using. And then we determined the ratios based on similarities between percent RSD and master charge values. The comparison criteria that we used, we started out looking at t-tests and ANOVA, but what we found was for the glass bottles, they were too variable to use these. But when we applied the plus or minus 2 standard deviations, this was a reasonable method for comparison. These are the instruments that, we used. The one on the left is the Perkin-Elmer Elon DRC2 ICP-MS, and the one on the right is the New Wave 213 laser. So for stage 1, when we used the plus or minus 2 standard deviations, we found 13 of the 15 ratios were indistinguishable, which is what we wanted for the purpose of this stage. We did 10 comparisons for each of the 10 bottles, which I'll show you what they were, and then I think it's the next slide. So we did have 2 ratios that were consistently problematic, SRZR and FECR. So what we did was we tried applying the plus or minus 3 standard deviations, and once we did that, all 15 ratios were indistinguishable. So this slide just shows the 10 comparisons that we made for each of the 10 bottles, and as you can see, for each of the 10 bottles, they were all indistinguishable. This is just showing you graphically. I'm sure you guys are all familiar with the match criteria that we were using. This just shows you graphically what we were looking at for the calcium manganese. Same for that one, same for that one. And as you can see, all of the ratios overlap, which is what we were looking for. So for stage 2, for the hourly time variable, we had 2 groups of 12 bottles. And when we ran these samples, we found that the bottles were all indistinguishable, except for in group 1, there was 1 bottle that was distinguishable from another, and in group 2, there were 2 bottles that were indistinguishable from another. And then when we compared the group 1 versus the group 2, they were distinguishable. So this just shows you the numbers of distinguishable pairs that we had. As you can see, most of the numbers are 0, but there are, for group 1, you're looking at 8, and the number in the parentheses is that I just wanted to look and see what would happen if we applied plus or minus 3 standard deviation, plus or minus 4 standard deviation for the problematic elements. So that's what that number means. So you are looking at some indistinguishable pairs. Distinguishable pairs. And those, again, were just the 1 bottle in group 1 and the 2 bottles in group 2. So for stage 2 daily, we had the 3 groups of 12 bottles each. And what we found for each of them was that there was a window where the bottles were indistinguishable from each other, but when you looked outside of that window, they were distinguishable. So that's what the number in the red is, 5 days, 8 days, and 4 days. The only exception was in group 3. There was 1 bottle that was distinguishable from all of the bottles except for the one that was farthest away from it in time, which was kind of odd. But other than that, they were all distinguishable outside of that window. So again, graphically, this is just showing you the number of distinguishable pairs, and you can see these numbers are a lot higher. And you can also see that there are trends in the ratios that we're using. Those are the ones that were typically distinguishable. So for the simultaneous daily variable, We were actually on time constraints due to when we had to submit the paperwork for this presentation. So we only had 6 bottles to work with for this. We had 2 bottles from furnace 1, 2 bottles from furnace 2, and 2 bottles from furnace 3. And as you can see, when we compare the furnaces to each other, they're all distinguishable. And when you compare the furnace 1 bottle to the other furnace 1 bottle, they were also distinguishable. But the furnace 2 to furnace 2 was indistinguishable, and the furnace 3 to furnace 3 was indistinguishable, which based on our hourly data we would expect, because these bottles were taken within a 24-hour, they were exactly 24 hours apart. So again, graphically, we're just looking at the number of distinguishable pairs. So the conclusions that we can make based on this research, bottles that are manufactured from the same furnace within a day are typically going to not be distinguishable, but we might expect that somewhere between 80 and 90% of the bottles manufactured within a day would share indistinguishable elemental profiles, so there may be some that would fall outside of that. For the daily bottles that we were working with, they were distinguishable outside of 4 and 8 days apart, and there was that one that was 11. And then for the simultaneous daily, bottles manufactured at the same time from different furnaces are distinguishable, and some bottles manufactured from the same furnace are distinguishable, even within that day period. So I just wanted to point out some significant information. This data does support some previous research. The Trejos-Almiral group actually did a study where they were looking at homogeneity of a bunch of different types of glass. One of the ones that they looked at was a 6-pack of beer and a case of wine, and they found that all of those bottles within their case, their respective case or pack, they were indistinguishable, which we would expect if bottles were being pulled directly off the production line and packaged that way. And also, it has been cited that indistinguishable profiles are typically from the same manufacturer, which we could even expand on that and say indistinguishable profiles are typically from the same manufacturer, likely within 2 weeks. And I just wanted to point out for the Gallo Glass Company, they're producing upwards of 1 billion bottles a year, 800 cases per hour. So if we're narrowing down our window to within, say 2 weeks on the same furnace, that's a pretty significant application for forensics. So some final conclusions. Of course, it's still important that when you're out at a crime scene, you're collecting and examining multiple fragments from your question sample. You want to get a really, really good representative sample of everything that you're dealing with. And that's basically just reiterating everything I already said. Future research, some directions I think that we should go. I'd like to go back and look at the refractive index of these glass bottles and see what sort of a variability that we're dealing with here. I'd also like to look at multiple manufacturers because, again, for this study, we're dealing with just one manufacturer, so whether or not this applies to other manufacturers would be something that we would need to look into. Also, I'd like to look at how bottles are distributed, how they're pulled off the production line and packaged, and how they're distributed out to vendors. And of course, more effective statistical studies. One of the things that I'm planning on doing for my thesis project is looking at principal component analysis to see if this is useful for this application. So just some acknowledgments to make. Thank you to the Sacramento County District Attorney, Laboratory of Forensic Services, and the staff there. They were all very helpful in this project. The Gallo Glass Company for donating all of our samples. The UC Davis Forensic Science Master's Program and the staff there, and the CCI. And I just wanted to point out that in your agenda, my email address is actually an old email. So this is the updated one. If you have any questions that you want to email me, you may want to copy that down.